Now, based off of these calculations from our logistic regression equation, we can calculate odds ratios. And so that's the next question that we're going to try to answer. What is the odds ratio for incident cardiovascular disease in obese people? And we should add the fact that we're comparing obese people to non-obese people. So our reference group is going to be non-obese people. We want to figure out kind of just how much more likely is it that obese people get cardiovascular disease than non-obese people. And so we can answer this question very easily by using the results from our regression equation. And the answer is that the odds ratio we're looking for is equal to the number e raised to the associated coefficient. And so this number e, this is the number 2.71 from high school algebra. So we're going to take that number, raise it to the value of the coefficient, and that's going to give us an approximation of our odds ratio. And so in this case, our coefficient of obesity was 0.658. We're going to take e raised to that number. We do that arithmetic, and we get 1.93. Now, this calculation you can do on a calculator very easily, or you can do it in Excel using this code right here. If you type EXP, that stands for exponential, and then in parentheses put the value of the exponent. You hit enter, and you'll get 1.93. Okay. So our interpretation of this odds ratio is to say that the odds of developing cardiovascular disease are about 1.93 times higher among obese persons as compared to non-obese persons. So this here stresses the point that our reference group is non-obese people, and so obese people are about 1.93 times more likely to get cardiovascular disease than the non-obese persons. Now, as our last example, we're going to look at example 9.9 from the textbook. And a little different scenario here. Question here, is having preterm labor related to mother's race and age? And so our outcome variable, or response variable, is having preterm labor. Now each mother either has preterm labor or they don't. So that variable is dichotomous, and so that means logistic regression would be an appropriate tool for analyzing our data. Now we have lots of different predictor variables. We have mother's race. Now this variable could take on lots of different values. It could be white, black, Hispanic, Asian, lots of possible values. And then age, that's another variable that could have lots of different values. Okay. And so what we're going to do here is we're going to take some data that we'll talk that the book never actually gives. All they give is the results from the data. But basically what happens in the data is they went out and they surveyed a bunch of mothers, recorded the race of each person and their age, and then whether or not they have preterm labor. And then we're going to use that data and we're going to perform regression analysis on it, and we're going to use the p-values from that logistic regression analysis to determine if age and race are related to preterm labor. And then also using those the regression analysis, we're going to calculate odds ratios for our different categories of races, where our reference group is white race. Keep this in mind when analyzing the results. The reference group is white race. And so the results are given here in table 925. The book never gives the raw data because that'd be very complicated to display. But what they have here is 4 different predictor variables. The first 3 are indicator variables. Black race, so that variable would equal 1 if the mother is black, 0 if they're not black. Hispanic race, that variable would equal 1 if the mother is Hispanic, and 0 otherwise. And then other race, again that's an indicator variable, and then the mother's age in years. And then we also have an intercept in our model. And so here's the values of the regression coefficients. Our intercept is negative 1.433. The coefficient of the black indicator variable is negative 0.082, and so on and so forth. Okay. Here's the values of the test statistics for the different hypothesis tests regarding the corresponding values of the regression coefficients. Here's the corresponding p-values. And so let's just analyze these p-values here real quickly. Remember that a large p-value would mean that that variable is not significant. A small p-value would indicate that that variable is significant. So we look at these p-values. This one here is large, this is large, this is large, this is large. The only one that's small is this one right here. So that means that apparently the only significant predictor variable is being of Hispanic race. The other variables, as well as the intercept, just don't appear to be significant. Now here in this last column, they give the values of the odds ratio calculated using those regression coefficients. So they took e raised to the 0.9039, and they got an odds ratio of 0.921. Likewise, here's the odds ratio for Hispanic race and other race, and then mother's age. And so, for instance, this number right here we could interpret as saying that the odds of a mother from the black race having preterm labor are about 0.921 times higher than white race. Remember that the reference group here is white race. So this one right here, 1.73, so that means that mothers from another race are about 1.73 times higher or more likely to get to have preterm labor than white race, and so on and so forth. Now, also given here are confidence intervals for the values of the corresponding odds ratio. Remember that an odds ratio, as we talked about in Chapter 7, an odds ratio calculated from sample data are a point estimate of the population odds ratio. So this is just a one-number estimate of the odds ratio from the population of the entire black race. This confidence interval gives us a range of possible values for that odds ratio. So for the black race, the confidence interval is anywhere from about 0.2 up to about 3.5. Now notice that that interval contains 1. So it's very possible that that odds ratio really does equal 1, which means that there's not a lot of difference between black race and white race. And that's exactly what this p-value is saying here, saying that being of the black race is not a significant indicator of having preterm labor. Likewise, if we look at this confidence interval here, that interval also contains 1, again indicating that this indicator variable of other race is not significant. This ratio, or this interval here, also contains 1, so that tells us that mother's age is not significant. But if we look here at Hispanic race, notice that this confidence interval does not contain 1. And so that's another indication that the Hispanic race is a significant predictor variable. Okay. So based off of this analysis, our conclusion is that the only statistically significant difference is between Hispanic and white mothers. So it looks like, based off our results, that Hispanic mothers are actually less likely to have preterm labor than white mothers. And the associated p-value here is 0.0021. Okay. So the odds ratio, according to our data, was about 0.208. And we would state that odds ratio as being adjusted for mother's age. Remember, when we calculated this, we also included mother's age in our analysis, and so that's an adjusted odds ratio. So that odds ratio of 0.2 would mean that Hispanic mothers are about 80% less likely to develop preterm labor than white mothers. So to summarize our brief discussion on regression, what we're doing in regression is looking for relationships between variables. In all sorts of regressions, we have exactly one dependent variable. We also called it the outcome variable or the response variable. We could have one or more independent variables, or we also called those predictor variables. When we do regression analysis, we get a p-value for each of our independent variables. The way we can interpret those p-values is a small p-value means that there is a relationship between the independent variable and the outcome. A large p-value indicates that there is not a relationship with the outcome. Now, when you do your journal readings, you're going to see lots of p-values given from regression analysis. And most of those p-values are going to come from logistic regression analysis. And so always keep this interpretation in mind. A small p-value means that there is a relationship between that given independent variable and the outcome. If we have a large p-value, then there is not a relationship with the outcome.